Hey folks, how are you? So I have tried to find another room in the house that's quiet, and yeah, it's not quiet either. You can probably hear my daughter in the background doing her vocal warm-ups for her music class. Yeah. So the struggle is real. Not just for you guys, but for me as well. We're going to get through this. Anyways, so we are now looking at properties of quadrilaterals. And so what I'm going to show you guys today is the various quadrilaterals and what those properties are. Duh. Okay, that's what properties of quadrilaterals means. All right, let me just get into this. So let me roll this thing around. All right, so what we're looking at, you have got on your eLearn page this flow chart. And the flow chart, I love this flow chart because it shows how the different quadrilaterals are all tied together. So what it shows you is that you start with the most basic type of quadrilateral, and the most basic type, the definition of a quadrilateral, you need to understand that the word lateral means side. Lateral means side, and you know that quad means four. So this is going to be a four-sided figure. So any four-sided figure is a quadrilateral, and there are no special properties other than the fact that it has four sides. But once you take your four-sided figure and you start doing some interesting different stuff with it, then your quadrilateral takes on different types of shapes. So let's say, for instance, we take this quadrilateral right here, and suddenly we say, you know what, I'm going to make this line and this line parallel to each other, and I'm going to make this line and this line parallel to each other. When you do that, suddenly your quadrilateral becomes what we call a parallelogram. So I've got a parallelogram here for us to examine, and remember what I said was that this side here and this side here were going to be parallel to each other. And the way that we designate that they are parallel is we put these little arrows on them. So that tells that this side and this side are parallel. Double arrows means that this side and this side are parallel. So that tells me that these two sides are not parallel to each other. These sides are not parallel to each other. Same thing here, but that these two sides are parallel and these two sides are parallel. So we got to think about what it means to have parallel lines. We talked about that before, and we said, okay, when you have parallel lines, you can take them and you can say, well, let me get my figure back here. I can say, okay, if these two lines here are parallel, and I didn't exactly do a real good job of putting those arrows in there, I guess this will do. Anyways, if these two lines are parallel, then remember, these two are same side interior angles. That means they're going to total 180 degrees. You can see very clearly that this measure and this measure are not the same. I don't even have to take a protractor and show that to you. You just know these two do not have the same measure. But what I do know is that this angle, I'll call it A, and this angle, I'll call it B. They total 180. Now, I also said that this side and this side were parallel to each other. So I'm going to put a single arrow and a single arrow here. If these two sides are parallel to each other, then that means that these two will total 180. So I'll call this one C, and that one's still B, but that means that C and B are going to total 180. So B plus C will be 180. So if that's the case, if these two total 180, and this one also totals 180 with that one, then what's that going to mean about these two? And you're absolutely right. That means these two have got to be equal to each other. So this angle right here is going to be equal to this angle right here. So, by the same idea, if these two sides are parallel, then these two angles should total 180. We'll call it D. So if D and C total 180, but C and B total 180, then what's that mean about D and B? Yep, they have to be equal. Now, I'm not going to put a single arc on these because then that would mean these two are equal. They're clearly not. I'm going to put a double arc and a double arc. And you can probably hear her singing up there, Chelsea. That's Ellie. Chelsea knows Ellie. That's Ellie singing. Anyways, So what I've figured out here is that within my parallelogram, and I'm going to go back to that flow chart again, what I know is that this angle is equal to this angle, and this angle is equal to this angle. So what it means is the opposite angles are going to be equal to each other within my parallelogram. Now, something else interesting about parallelograms, and I'm going to take the shape that I've got right here, and I'm going to talk about the sides of the parallelogram. So if I measure the sides, and let's go with this one down here, its length is going to be 10 centimeters. And I measure this one up here. Oops, that's not quite, it's a little bit more than 10 centimeters. That's going to be 10.3 centimeters. Which means I better go back and double check this one again. Yep, 10.3 centimeters. Sing it, Ellie. That's right. That kid's got pipes. Anyways, so these two sides are equal to each other. And now let's check this one over here. Okay, we've got 8.2 centimeters. And this one up here is going to be, yep, 8.2 as well, 8.2 centimeters. So what that tells me is the opposite sides are equal to each other within the parallelogram. Not all four, but the opposite sides. So as I look at my flow chart, then that means not only are these two sides parallel, but they're equal. So I'm going to put a single tick mark to show that they're equal. Tick marks show that they're equal. And I'll put my double tick marks here. Arrows show that they're parallel. Tick marks show that they're equal. I'll put my double tick marks there. Now, the last thing that we want to look at within the parallelogram is we want to be able to compare the diagonals. Now, what diagonals do is they go from one corner to the other corner. In other words, from one vertex to an opposite vertex. And well, that's it. They go from one vertex to an opposite vertex. So if I take my parallelogram that I have here, and I'm going to flip it to the other side so there's too much writing on here, I can't see real well. So I'm going to draw my diagonal going from here to here. And I just got to tell you guys, this is what I'm super duper crushed about at this point in our semester. I was so excited to show you guys and have you guys cut out the shapes. We were going to, remember Destiny, we talked about, you've never had a geometry class with me. You're going to love geometry because of the way I teach it. And unfortunately, you don't get to have all the fun that I wanted you to have with cutting these shapes out and measuring them and folding them and stuff. I'm just crushed. Anyways, so if we take a look at these diagonals within that parallelogram, and if I measure this one, let's go with centimeters again. I've got 16 centimeters on this one. And on this one, I've got 8.8 centimeters. So they're definitely not equal to each other. By no means are they equal. And you, I mean, you could see there's no way that that big long diagonal is going to be the same as this short little diagonal. But watch the other thing that can happen here within a parallelogram is that this is going to be 8 centimeters, just this much. And then this one is also going to be 8 centimeters. So, and on this one, if I measure it, I've got 4.4. And I'm betting that this side is 4.4. And sure enough, it is 4.4. So what that shows is the diagonals aren't equal to each other, but they certainly bisect each other. Bisect means cut in half. And so this half is the same as that one, and this half is the same as that one. So the diagonals of a parallelogram are going to bisect each other. Now, if I was to measure the angles here that are formed by that parallelogram, by the diagonals, you can see that it's about 105 degrees here. And that would mean if this is a straight line, that means this one's going to be 75. Because remember, straight line's 180. Vertical angles are equal. So this is 105 and this is 75. So what I'm trying to point out here is, by all means, they're not right angles. So the diagonals of a parallelogram are not going to make right angles. And that's pretty much all I need to show you about the parallelogram. Now, let's take a parallelogram and let's say if we took this parallelogram, which we already know that the opposite sides are going to be parallel to each other, opposite sides are going to be equal, opposite angles are equal to each other. If we took this parallelogram and we shifted it so that now these angles, which clearly you can see they're not 90 degrees, there's no way that's 90 degrees. It's actually, let's see here, 56. And if this is 56, that means this one has to be, oh golly, 180 minus 56, and suddenly I just can't think straight. There we go, 66. So they're definitely not 90 degrees. But if I would take this parallelogram and I would shift it so that suddenly we've got 90-degree angles, what I have formed is a rectangle. So a rectangle is a parallelogram. It is a parallelogram, and so therefore these sides are going to be parallel to each other. They are also going to be equal to each other. And these sides are going to be parallel to each other, and they're also going to be equal to each other. And because it's a parallelogram, that means that I'm sorry, all of a sudden I blanked out. Oh, the opposite angles will be equal to each other. But notice that within this rectangle, now I suddenly have 90-degree angles. And you can see, yes, in fact, that's a 90-degree angle right down here. And if these are parallel, that means this has got to be 90. And same token here, if these two are parallel and that's 90, then this has to be 90. And by the same token, if this is 90 and these are parallel, that has to be 90. So that's the properties of a rectangle, is that the opposite sides are going to be parallel to each other, as well as equal to each other. Parallel, parallel, and equal, because they are parallelograms. But in addition, the opposite angles will be equal, but the opposite angles have a little bit more of a special characteristic now. Those opposite angles are definitely going to be 90 degrees. Now with that rectangle, the interesting thing is those diagonals, they do not necessarily bisect each other anymore, because take a look at this rectangle, and when I flip it over and I take that and I make that diagonal going from here to here, and I make the other diagonal going from here to here, if I measure from here to here, I will get 5.1 centimeters. And if I measure from here to here, I get again 5.1. And if I measure from here to here, I get 5.1. And if I measure from here to here, I get yet again, yes, 5.1. So actually, I'm horribly mistaken, and I'm so sorry I said this, because the diagonals are going to bisect each other. Because if it's a parallelogram and the diagonals bisect each other, if that's the case of a parallelogram and a rectangle is a parallelogram, then yes, the diagonals will bisect each other. But when you have a rectangle, the diagonals do something even more special, and you'll notice that this distance here of 10.2 and this distance here of 10.2 are equal. So not only do the diagonals bisect each other, the diagonals are equal. So diagonals bisect each other, and diagonals are equal. Now, if we take a look at our parallelogram and we do something different to it, we don't necessarily shift it so that these become right angles in here, but instead we say, let's keep it tilted, but let's make sure that all four sides are equal. When we do that, suddenly our parallelogram becomes what we call a rhombus. And so here I've got a rhombus. Now, because this rhombus is a parallelogram, remember that means these opposite sides are parallel to each other, definitely. The opposite sides are equal to each other, definitely. Parallel, equal. But now, actually, I mistakenly labeled this because now all four sides are going to be equal. So I really should have double marks on every one of these because now all four sides are going to be equal to each other. Now, these two are not parallel. And these two are not parallel, so it's okay that I only put a single arrow here and double arrows here, but all four sides are equal. Now, if you'll notice, remember I said that the rhombus is not going to have 90-degree angles, and you can clearly see that's not 90, that's not 90. There's no way that those are 90. But let's check those diagonals again. Actually, before we check the diagonals, remember, what I do know, though, because this is a parallelogram, and remember, parallelogram opposite angles are equal, so these two angles are equal. And sure enough, if I check, this angle is, let me see here, 130. And this angle here is, yep, as well 130. And so that means that this one has got to be, I'm sorry, blanking out, 50. And so this one has to be 50. So the opposite angles will definitely be equal because it's a parallelogram, but all four sides are equal. So now let's check those diagonals. And if I draw the diagonal here, and draw the diagonal here, you can clearly see the diagonals are not equal to each other. Remember, that was the case whenever you had a rectangle. Rectangle diagonals are equal, but clearly not happening here in this rhombus. However, because that rhombus, remember, because it is a parallelogram and the opposite sides are parallel to each other, then what that means is those diagonals are definitely going to bisect each other. Diagonals bisect each other. But the other thing that happens that's interesting with our rhombus is the way that these diagonals meet each other. So if I check this out, oh yes, it's 90 degrees. And vertical angles are equal, so this is 90 degrees. This is a straight line, so that has to be 90. Vertical angles are equal, so that's going to be 90. So the diagonals, not only do they bisect each other, but they form right angles. And in addition to that, the diagonals do another thing very interesting. And the other interesting thing that they do is what they do to the opposite angle. So if I take a look at this angle right down here, you can see that that angle is, let's see here, we got 66 degrees. And so let's check this angle right here. Yep, 66 degrees. Oops, sorry. And that will happen on all those angles of that rhombus. So over here, I'm going to have yet another 66 degrees. We can just double check real fast. Okay, more like 67. And check this one. That shouldn't happen. It should be 66, but it's probably lack of precision on my part. Yeah, because that one's, yeah, I think it's because I didn't draw the diagonal very well. It should be 66 and another 66. If we check over here, we will have, let's see here, that's 26. And we should get another 26 on this one as well, but we'll double check. And let's see here again. I think it's lack of precision on my part because I'm getting 25. But it should be equal, and so that should happen down here as well. So the diagonals bisect each other, they form right angles, and also those diagonals bisect opposite angles. So that's what a rhombus does. And again, the beauty of this flow chart that's here says, okay, I'm starting with a four-sided figure. I'm taking that four-sided figure and I'm making opposite sides parallel to each other. Now it becomes a parallelogram. Not coincidentally, but because these sides are parallel, the opposite angles will be equal and those diagonals will bisect each other. And those are the characteristics of a parallelogram. When I take that parallelogram with all those characteristics and I put four right angles in these corners, now it becomes a rectangle. And now not only do the diagonals bisect each other, but they are equal to each other. Then if I take my parallelogram and I keep that tilted shape, but I make all four sides equal, now my parallelogram becomes a rhombus. So that means that the opposite sides will definitely be parallel, but all four sides are equal. And yet again, these opposite angles will be equal, but they're not going to be 90 degrees on them. The diagonals will bisect each other because it's a parallelogram. They will form right angles, which is a little different, and they will bisect opposite angles, which is a little different. Now, if I take these two figures, if I take this rectangle and this rhombus, and I smush them together, then what I get is a square. So here's my square. So the square has all the characteristics of that parallelogram because it is a parallelogram. So my opposite sides will be parallel to each other. Parallel, parallel. The opposite sides will be equal to each other, but remember, this was a rhombus that got smushed together with a rectangle. A rhombus, all four sides are equal. So my square is going to have all four of these sides equal to each other. But because it's a rhombus smushed with a square, not only are these opposite angles equal to each other, they also have four right angles in those corners. But because it's a rectangle, well, actually, let me step back. Because it's a parallelogram, that means when I make the diagonals are going to bisect each other because it's a parallelogram. And so this measure will equal that measure, and this measure will equal that measure. And sure enough, I can double check, and this is going to be 5.5 centimeters. And so this as well ought to be 5.5. I did a better job there. Okay, 5.5. But remember, because it's a rectangle, these should have the same length. So in other words, this being a total of 11 centimeters, this as well should be 11 centimeters, and sure enough it is. And so from here to here is 5.5. Because it's a parallelogram, they should bisect each other, and this is as well going to be 5.5. That's because it's a parallelogram that these are going to bisect. Because it is a rectangle, they're going to have the same length. Because it's a rhombus, I'm going to have right angles in here. And sure enough, I can double check and I can see, yep, not well, terrible precision here. 90 degrees there. And again, hopefully the precision will be right. 90 degrees, though, the precision is awful. So I should have 90 degrees on each one of these. And in addition, remember, these opposite angles will be bisected from each other. So this angle will equal this one. This one will equal this one. Now, because these two are equal, remember, it's a parallelogram, so opposite angles are equal. So that means that this one, this one, this one, and this one will all be equal. This one, this one, this one, and this one will all be equal. Well, incidentally, all four of them are 90 degrees. They're all equal. So frankly, they're all going to be equal to each other. And this is because we took a rhombus and a rectangle, we smushed them together and created this square. So in our flow chart, our square, because it's a parallelogram, is going to have opposite sides that are parallel. All four sides are going to be equal because it's a rhombus. Going to have four right angles in those corners because it's a rectangle. But now, because it's a parallelogram, the diagonals will bisect each other. Because it's a rectangle, the diagonals are equal. because it's a rhombus, the diagonals form right angles. And because it's a rhombus, the diagonals bisect opposite angles. Now, that's if we have a parallelogram where we have two pairs of parallel sides. Remember what I started with was saying that in my parallelogram, these two sides are parallel and these two sides are parallel. But what if we only have one set of parallel sides? If that's the case, we don't have a parallelogram. What we have is what's called a trapezoid. A trapezoid only has one pair of parallel sides. Now, I brought a trapezoid with me. This, frankly, is an isosceles trapezoid. Trapezoids don't have to have this look to them. For instance, you can see in this picture right here, as long as I got one pair of parallel sides and the other two sides are not parallel to each other, I have a trapezoid. We are just used to seeing trapezoids that look like this. But if I would kind of fold it over a little bit so that it looks like this, quite honestly, that's a trapezoid because I only have one pair of parallel sides. But like I said, this is the type that we're used to seeing. Now, trapezoids don't have any super special characteristics. Without a doubt, we do have parallel sides here. I'll try to put my arrows in there like that. But you can clearly tell these sides are not equal to each other. And that's not going to happen in a trapezoid. What will happen is, remember, these two will add up to 180, and these two will add up to 180. But you can see most definitely these two are not equal to each other, and these two are not equal to each other. So when I have a trapezoid, all I really know is, let's call this A and B. I can say that A plus B is 180, and we'll call this C and D, and I know that C plus D is 180. But I can't necessarily say that these two are equal, and you can see that they definitely aren't. So that's all I can really say about a trapezoid. But if I take a trapezoid and I make the two sides equal to each other, and that's what happened in this case, you can check that measurement, and we've got a 6.7 centimeters there. And see, I thought that was 6.8. Yeah, 6.8 centimeters on each of those. I was having a hard time seeing it. So I got 6.8 centimeters here, and I've got 6.8 centimeters here. So when those sides are equal, and this side is equal to this side, then we have what we call an isosceles trapezoid. This is what an isosceles trapezoid looks like. Definitely a trapezoid because I definitely have this one pair of sides parallel to each other, but now I know that these two are equal. Notice I don't have any arrows. They're not parallel, because if they were parallel, this would be a parallelogram. But I only have one pair of parallel sides, so it is a trapezoid, but now it's isosceles, like an isosceles triangle. An isosceles triangle has two equal sides. When you have an isosceles trapezoid, these two angles down here will be equal, and these two angles up here will be equal. So if I take this and I measure it, and hoping that my precision is right, I'm getting 66 degrees. And if I go measure this one, I should get 66 if precision is okay. Yep, 66 degrees. Now remember, these will total 180, so this one had better be 114. And that means this one should be 114. So if we check that, yep, 114. And my precision's off. Yep, 114. So that's what happens when you have an isosceles trapezoid. There's nothing more that you can say about it other than that. So let me put my marks on here that these two angles will be equal and these two angles will be equal. That's all I know, other than that these two will total 180 and that these two will total 180. But that's going to be the case when I have a trapezoid, that these two will total 180 and that these two will total 180. So the last figure that we're going to talk about with a quadrilateral, remember quadrilateral means four sides, is a kite. we had a situation where we had a parallelogram that had two pairs of parallel sides. We had a situation with a trapezoid where we had one pair of parallel sides. So if we keep going down, that means a kite has no parallel sides at all. So I brought a figure of a kite, and you're used to this being the shape of a kite. What you can say about a kite is that these two consecutive sides will have the same length. If I check the length on this one, let's go to my centimeter side. I got 6.4 centimeters. And check the length on this one. I've got, 6.4 centimeters. Now if I check the length of this one, I've got 12 centimeters. And let's double check this one. It should be 12. Yep, 12 centimeters. So that's what happens whenever you have a kite, is you're going to have these consecutive sides being having the same measure, but no sides are going to be parallel to each other. Now, interestingly, if you do a diagonal within a kite, drop a diagonal there, drop a diagonal there. I didn't do diagonals in that trapezoid because there really wasn't anything special about those diagonals. But you can see that within a kite, those diagonals make right angles. So I've got, 90 degrees right here. And remember, vertical angles are equal. Straight line here, so that's got to be 90, that's going to be 90. The other interesting thing about a kite is these diagonals. This one will be bisected, but this one clearly will not be bisected. So if I measure from here to the end, I get a 5.3. And if I measure from here to the end, I get, another 5.3. But like I said, this one's clearly not bisected. And that honestly is all that we know about a kite. We know that these two consecutive sides are the same. These two consecutive sides are the same. Nothing is parallel at all, but the diagonals will make right angles, and the diagonal here will be bisected. So, like I said, this flow chart is fantastic for knowing all these relationships about these quadrilaterals. And what you're going to do now is you're going to print off this check sheet, and you're going to take what we discussed here and you're going to transfer it to the check sheet, and then you're going to upload that and send it to me. One thing I do want to point out is we did not talk about diagonals forming congruent triangles, so I'm going to go ahead and give that one to you, that if you have a parallelogram, the diagonals will definitely form congruent triangles. It is because, and if we pull that parallelogram back out, it is because I've got this side equal to this side, and I've got this side equal to this side. So if I take a look at this triangle up here and this triangle down here, then I've got two sides that are congruent, these two sides that are congruent, the angles between them are congruent. There is a property called an SAS, side angle side property, that says if two triangles have corresponding sides and an angle between those sides equal to each other, then the two triangles are congruent. And that will happen here as well. So, like I said, if you have a parallelogram, the diagonals will definitely form two congruent triangles. And remember, a rectangle is a parallelogram, so therefore, true here. A rhombus is a parallelogram, so therefore true here. A square is a parallelogram because it's a combination of these two, so it's true here. So as you go through this chart, what you're going to do is you're going to fill this out for a parallelogram, and then remember, if it's true of a parallelogram, it has got to be true for the rest of these. If it's true for a rectangle, it has to be true for a square. If it's true for a rhombus, it has to be true for a square. So, hopefully, these relationships on these quadrilaterals make sense to you. If you have any questions about it, please don't hesitate to ask me. I'm always here for you. I'm always available for you. And yeah, just I'm going to send an email to let you guys know how to submit everything and where we're going to go from here. So I miss you guys, and I hope everybody's okay, and you all take care. Bye.